Hello, my name is Isatun Binta Ashari. My mentor number is CE220122, and I'm about to explain about my part in this project data communication. I want to explain about this basic network that using hub. Okay, first we using hub, and we use 5 PC, which is PC1 until PC5. Every PC we have to input the IP address, which is at PC1 is 192.168.0.1. Also at the PC2 0.2, at the PC3 192.168.0.3, and so on. Okay, at this part we want to test if we success or not to send the data from PC1 to PC5. Okay, let me try. We open the PC1 and desktop, then go to the command prompt, and we test with ping. We insert ping 192.168.0.5 because we want to send at the PC5, and we insert the number of data that we want to send, and the instruction we want to send 20, so and 20. Then we press enter, then the data start to send, which is 20 data. And here is the result. At the last, we got the result, which is the packet sent is 20, received 20, and no loss. Okay, right now I want to explain about the second part, which is we use switch. At the first part we use hub, and now we want to use switch, and we also use the same value of PC, which is PC1 until PC5. And right now we want to test if the data sent at the PC1 until PC5 is successful or not. And by using switch at the PC1, we go to the command prompt, and we insert the ping 192.168.0.5 because we want to send at the PC5. Then we insert the value of data, which is 20 and 20. Then we enter, and there's the data show that have successfully sent to the PC1 sent to the PC5 from the PC1. And at the last, the data show that the packet was sent 20 is successful, received successful 20 data, and no loss. That's all. Thank you.
After that, I tested communication from PC1 to the PC10. And then we wait to the which is we know the PC1 and PC2 is in different networks, so the data had to pass through the router 1, and I also sent 20 echo requests, and then pings were successfully. However, the reply time was slightly slower because the packets had to be routed. So I will repeat the simulation for the second part. As you can see, the packet will go through the router 6 and then go to the switch number 2 and then go to the PC10. So finally I compare the both result. So pinging with the same lane, which is PC1 to the PC5, was faster because it didn't need to go through the router. But pinging between LAN A and LAN B, which is PC1 to PC10s, still worked fine because the router helped the data travel between the two networks, but was slightly slower because it difference in PC1 is and PC10 has different networks, and this show how routers are important for connecting different networks. That's all for this part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar Haikal bin Fazrul Hisham. My matrix number is AE220129. So first, for this task, we need to configure two VLAN, which is VLAN 10 for PC0 and PC1, and VLAN 20 for PC2 and PC3. So as you can see here, I already use switch and then for PC, which is PC0. If you can see right here is it's 192.168.10.10, and for PC1 is 0.10.20, and then for PC2 right here is 192.168.20.10, and for lastly for PC3 is 0.20.20. So that is the IP address like the question. So for the VLAN part, I already configured it in the switch CLI, which is right here. As you can see, I already did this for the switch port access for VLAN 10, and then this one for this one, which is fast Ethernet 01 and 02 for VLAN 10, which is PC0 and PC1, and then for fast Ethernet 34 for VLAN 20, which is I assigned it for PC2 and PC3. So we look again at the brief, at VLAN brief. So this command show VLAN brief, and then it will show that for VLAN 10 is active for fast Ethernet 01 and 02, as I mentioned before, and VLAN 20 is active for fast Ethernet 03 and 04. So after we configure all of this, we can try to ping PC0 and PC1 first. So let's do that. So ping. So for our PC1 is 192.168.10.20. So this is, we do this at PC0 and we ping to PC1. So as you can see here, we have packets that we send is 4 and we receive 4 too, which is no losses at all. So it's working fine because it's in the same VLAN. So next we try to ping from PC2 to PC3 right here. Ping 192.168.20.20. So this is the IP address for PC3 right here. So we try to ping. So as you can see, we send 4 and we receive 4, and with 0 loss. So it is true because it is on the same VLAN. But if you try to ping PC0 to PC2, it should be not getting any result because it is in the different VLAN. So we try to ping, okay? Ping 192.168.20.10. So this is the IP address for PC2 right here. But we did this on PC0. Now it's pinging. Look, we don't get any results. Wait, we should wait. So we wait a bit. It shows request timeout right here 3 times, and then it shows that the ping statistic that we do. So we send 4 and we receive 0. So we have 4 losses, which is 100% losses. So yeah, this is correct because it is not in the same VLAN. So that's all for me. Thank you. Okay, now we move on to the second part of the task, which is we implemented the 3-layer switch right here. We changed the switch to the 3-layer switch, and in this part also we use 4 PCs, which is PC0, PC1, PC2, and PC3. As you can see, the IP address of all the PCs are still the same. Right here. .20.10, and lastly 0.20.20. So this is still all the same IP address, but later in this part we will see. Okay, for the switch, we already configured the VLAN. So as you can see, I will show the VLAN brief right here. So as you can see, for VLAN 10 is active for Fast Ethernet 01 and 02, and VLAN 20 for 03 and 004. So for the VLAN 10 is for PC0 and PC1, and for VLAN 20 is for PC2 and PC3. So what is different than before is we use the layer 3 switch, and we set the default gateway, right? Oh, sorry. Right here. We set up all the default gateway by 192.168.10.1. So it's all the same default gateway. So why do we do this? Is because this will allow all the PCs to send packets to other VLANs through the layer 3 switch, which is we use here. So we need that gateway. So now we will try to ping PC0 to PC1 first. Right here. So ping 192.168.20. So this is the IP address for PC1. As you can see, we receive all the packets and we have 0 losses. Now we try to ping PC2 and PC3, which is in the same VLAN. Ping 192.16.20.20. So this is the IP address for PC3. So we try to ping. And then we have no loss again, and we receive 4 packets. And now for the final part, which is we should be able to ping from PC0 to PC3, which is have different VLAN, right? This one is VLAN 10 and this one is VLAN 20. So we try to ping 192.168.30. So this is from PC 10 to PC 3, okay? As you can see, we have no losses. It is still the same if we try to ping it to PC2, which is on the other VLAN. So this is the IP address for PC2. Okay, we have send 4 and receive 3. This is because of the delay. So we can try to ping it again. So I try to ping it again. And now it becomes normal. Send 4, receive 4, and lost 0. So it is normal in Cisco. We have a bit of delay. So from that, we can confirm that the inter-VLAN routing is functioning correctly through the multi-layer switch right here. So that's all from me. Thank you.
Hello, my name is Zaitun Nazira binti Ashari. I would like to explain about my part at the OSPF part. In this project, I was required to configure a network using OSPF routing protocol. The topology consists of the three routers, which is router 1, router 2, and router 3. Each router is connected to a different line. Router 1 is connected to the 192.168.1 and 0.1, and this is the subnet mask 255.255 and 0.255, and this is the serial IP address, which is 10.1.1.1, and the subnet mask is 255.255.255 and 252, and this is the serial 3 IP address, which is 10.1.3.1. The subnet mask is 255.255.255 and 252. Also, at the others router, I also set the IP address at the fast internet 192.168.2.1. The subnet mask is so on the same like at the router, at the first router, and this is the serial port. We just change the value of the 1. We replace the 1 into the 2, and this is the subnet mask, and this is the serial 3 IP address. And at the router number 3 also have the same IP address, but we replace the 2 with 3 because it's defined to the refer to the router 3, and this is the serial port IP address, and this is the serial port IP address also at the serial 3. So the router are connected to each other using serial point-to-point links, which is the IP address in the 10.1.1.1 like at the serial port each router. To allow the communication between all lines, I use OSPF, which stands for Open Shortest Path First. OSPF is a dynamic routing protocol that allows router to automatically learn and exchange routing information. It operates at layer 3 of the OSI model and uses Dijkstra algorithm to calculate the shortest and the most efficient path for the data travel. So then I advertise each connected network using the network command. For example, for router 1, configure network this the this. So I will I will try the simulations directly, like in the instruction we want to send the data from PC10 to PC2. So at the PC10 we go to the command prompt and then we insert ping 192.168.2.2, and this the pinging, and still we got request timeout at first, and we will try again. 192.168.2.2. And the data show that send 4, receive 4, lost 0. Hello, my name is Aitunazia. Okay, next we move to the next instruction, which is we want to send the data from PC10 to PC4, and at the PC0 to PC4, to go to the command prompt, and we do the same step, which is we type ping 192.168.3.2 because at the PC4 IP address is 3.2, so we insert the destination IP address. We click enter, and still in process to get to for the data send. We got the PC4 just received the 3 data, so we try again 192.168.3.2. Then lastly it was successfully sent to the PC4. Okay, next to make sure that our project is successfully with the OSPF connection or not, we want to try from PC2 to PC4, which is at the PC2 we go to the configuration, we go to the desktop, we go to the command prompt, and we insert the ping 192.168.3.2. so let's see. Okay, the data was successfully sent and received 4 data. At the OSPF is just it for the OSPF connections, and in conclusion, OSPF is allow all router in my project to dynamically share network information and forward data efficiently across different lines. This made the network more scalable, easier to manage, and capable of handling future growth. That's all. Thank you.